This is 2.5 quadratics. Okay, let's look at our standard quadratic equation, which is ax squared plus bx plus c. Remember, on your standard equation, if your a value is greater than 0, then you're going to have a parabola that faces up, and you're going to have a minimum vertex. If a is less than 0, then you're going to have a parabola that faces down, and you're going to have a maximum value or a maximum vertex. And if a is equal to 0, then you're going to have a linear function. Okay, let's look at f of x is equal to a parenthesis x minus h. This quantity is squared and plus k. This is your vertex form. And you get to your vertex form by completing the square. And I know we've done, you did this last year, but there's always different ways to do this. So this is how I start. I take these first two. Remember, your first value cannot have a coefficient, so I'm going to factor that out. So take out a 2. That gives you x squared minus 6x. I'm going to leave a blank inside my parentheses. Add 23. And I'm going to bring a blank outside. Your whole deal with completing the square is that you cannot change your equation. So you're basically adding an imaginary 0 to this equation. I'm going to take this value right here, your b value, and I'm going to half it. I'm going to box it and square it. So when you take negative 6, half it, that gives you negative 3. You square it, that gives you 9. Okay, if I were to counteract this, this would be a negative 9, so that would give me a 0. But since I have a 2 right here, this is really a positive 18. So I'm going to subtract to 18. And this is where people really mess up, so make sure that you don't forget that number out there. Okay, I basically have finished my problem, so I'm going to say f of x is equal to, I still have my a value, which is 2. I have an x. The box tells you what is inside this. So this is minus 3, this quantity squared. Then take 23 minus 18, and this is what's outside. This is your k. This is now in vertex form. We use vertex form to find basically your center or your vertex of your parabola. So I'm going to say vertex. And since your original problem is negative h and a positive, this is, what did you plug in to make this negative? So my vertex is 3, 5. I can find my axis of symmetry, and so I'm going to call it the AOS, the axis of symmetry, and that is x equals 3. I'm also going to tell you that the vertex, I could have found the vertex for my original problem up here by using the formula negative b over 2a, just for those of you who like different things to do. My negative b would be a positive 12 over 2 times a. That would be 2 times 2. So this would be 12 over 4, which is which is 3. And that's what I got right there. I'm also going to find your x-intercept, because I am eventually going to graph this. On an x-intercept, I know that y is equal to 0. I'm going to go ahead and use, it's not going to matter if you use your original or your vertex form, just whichever one you like the best. I'm going to go ahead and use vertex form. So negative 5, 2 equals 2, x minus 3. Divide by 2, so that's negative 5 halves, is equal to the quantity of x minus 3. You're going to have to square root both sides. So you have x minus 3 on this side, and you have the square root of a negative number right here. Since we have the square root of this negative number, that means I'm going to have an imaginary, something imaginary. So I'm basically done, and I'm going to say that I have no x-intercept. When you get an imaginary number right here, that means that your parabola is not going to touch your x-axis. Let's find our y-intercept. On a y-intercept, your x is equal to 0. So I'm taking my equation again and saying y equals 2 times, plugging in a 0 for your x value. And when I do that, I get 23. So your y-intercept is 0, 23. I want to now graph this. So I have a vertex at 3, 5. So this is the center. Axis of symmetry is going to go down here in the middle. I'm not really worried about that. It's not going to touch my x-axis, but I do have a y-intercept at 0, 23. It's way up here at 23. Since this is your axis of symmetry, I know that if I go over 3 more, that I'm going to have another point at 6, 23. And then I can sketch a parabola, and it will look somewhat like this. So number 2, let's do f of x equals negative 2x squared plus 4x and plus 4. Again, we need to factor out our negative 2. So if you take out that negative 2, that gives you x squared, and this gives you minus 2x. I'm leaving a blank inside, adding my 4 outside and a blank outside. If you want to pause this, go through your process of completing the square and see if you get the same thing I do, that would be a great idea. Take your middle term and half box square it. You half the negative 2, that gives you 1, square it, you still get a positive 1. Remember, normally you would counteract this by saying this is a negative 1 over here, but you have this number outside, so this is really a negative 2, so I'm going to add 2 outside. And now I can write my vertex form. Negative 2 inside my parentheses, use your box for that, so this is going to be x minus 1. And then on the outside, combine these to get 6. From here, you can find your vertex. Your vertex is going to be a positive 1 and a positive 6. This negative 2 out here has nothing to do with your vertex. Your axis of symmetry is going to be x equals 1. The only thing this negative 2 has to do with is to tell you that the parabola is going to be facing down. Okay, we need to find our x and y intercepts. X-intercept, that means your y is 0. So taking my equation here, this gives me 0 equals negative 2, an x minus 1 quantity, and add 6. So you take the 6 over, and we're going to divide by 2. Have an x minus 1 quantity divided by 2 over here. This gives me a positive 3. I'm sorry, when I square root both sides, I have a 3 here, and I have an x minus 1. This is actually going to be a positive and negative 3. So when I add the 1, my x is going to be 1 plus or minus the square root of 3. Okay, let's find the y-intercept. Remember, that's when x equals 0. So y equals negative 2, 0 minus 1, quantity squared, plus 6. That's going to give you a y value of positive 4. So 0, 4. All right, let's try to graph this. Okay, vertex 1, 6. And remember, this is facing down. So here's my axis of symmetry. X-intercept of 1 point. Oh, I don't want to do that yet. Let's do 0, 4. 2, 3, 4. So I know it's going to face this way, so I can do an opposite one of 4. So I know this. Okay, so how am I going to do an x-intercept of 1 plus a little bit more? I'm going to do 1 plus a little bit more, so I bet it's going to go through here, or this is the 1 minus, and then from here, 1 plus a little bit more is going to go here. And that's just kind of guessing. It's got to be over 1. I don't know what 0.3 is. Well, it's 1.5. So we need to go a little bit further. And that is a good representation of this parabola facing down. Okay, if y'all have questions, bring them to class.